Good day, class. This is AS Mathematics paper Pure Math 1. So in chapter 1, we have this topic. This is part of chapter 1. So I'm starting with method of completing the square. This is after solving quadratic equation. So I want to know, how do we solve completing the square? Now, to solve this, let's start with number 1. You can only solve completing the square where the coefficient of x squared is 1, and that's the case here, right? So we can solve from here. So what we do is that we write this x, open bracket, x signs plus 6 out of 6 is 3 squared minus that same 3 squared plus 1. Therefore, we have x plus 3 squared minus 9 plus 1, that is x plus 3 squared minus 8. Second question, open brackets, x, negative sign for the middle one, negative sign in the brackets. Half of 4 is 2, close bracket. So half of 4 is 2 in bracket, minus here, minus in bracket. Then outside bracket squared. Then minus these 2 squared minus 8. Notice that no matter what is in the second one is not to be in the bracket. There is plus on the middle one, there is plus in the bracket. Minus it with the middle one, minus in bracket. No matter what you are putting in the bracket, outside should be negative 3 squared, negative this 1 squared, negative this 2 squared, okay? Not because of this minus, because it's outside the bracket. Now, from here, I say that this is x minus 2 squared minus 2 squared is 4. 4 minus 8. We have x minus 2 squared minus 12. Now, let's look at the next question. Now, when it is an equation, what do we do? Again, I'll take bracket x plus half of 12 is 6 squared minus 6 squared plus 16 equal to 0. So x plus 6 squared minus 36 plus 16 is 0. X plus 6 squared minus 36 plus 16 is minus 20 equal to 0. Now, I can continue by taking this 20 to the other side. So x plus 6 squared becomes 20 across becomes plus 20, positive 20. So x plus 6, by the time I square root both sides, I'm going to have root 20, but it will be positive and or negative. Hence, hold on, let me scroll up. Okay, that is x plus 6 becomes, okay, then I can say that, let me just take that across. So x can become minus 6 plus or minus root 20. So x is, the smaller one should be having negative here. The bigger one should be having positive here. So the smaller one is minus 6 minus root 20, or x is minus 6 plus root 20. Notice that this 20 this minus 6 will be minus for both of them. Minus 6 here, minus 6 here. It doesn't change. But the 20 is negative here and positive here. Number 4. What if the middle one is negative? X, or what if the middle one is not even number? X minus half of 7. I don't want to write 3.5. So let me write it as a fraction 7 over 2 in bracket squared. Whatever is there, minus. That's 7 over 2 squared plus 15 equal to 0. Now, x minus 7 over 2 squared minus square 7 is 49, square 2 is 4, plus this is 15 over 1. X minus 7 over 2 squared minus plus the size. Okay, let me just say that this is minus 49 over 4, or better still, you impute everything here on your calculator. No, sorry, mistake. Input everything here on your calculator like this with this sign, minus 49 over 4 plus 15. When you do that, what will you get? You're going to get something like, this is 60, to get positive 11 over 4 equal to 0. Now, to continue solving this, then x, I think I have to change this question because I'm going to get a very funny answer if I continue. I don't want to get a funny answer, so let me make it 5. I'm going to make it 5, not. So let me make it plus 5, plus 5, plus 5 over 1. So I don't want to get math error, because I have to do math error. So minus 49 over 4 plus 20 over 4, I'm going to get minus 29 over 4. So x, but let me just use that to replace everything here. Because of space, for the sake of space, I have minus 29 over 4. So I take this across. So I have x minus 7 over 2 becomes positive 29 over 4. Okay, this one is still squared. So x minus 7 over 2 becomes square root of 29 over square root of 4, which happens to be 2, so that this one can become 2. This can become 2. This can be, this is 0 root 29, and this is 2. So I can say x is minus 7 over 2 across becomes 7 over 2. And then forget after looking for square root, you have positive or negative. So that should be positive or negative root 29 over 2. Which should be, sorry, I have to move my question down a little bit. Minus 3x squared minus 6x plus 5 equal to, okay, and this gives me 7 over 2 minus root 29 over 2, or 7 over 2 plus root 29 over 2. So now let's go on to number 5. I have this. In this case, the coefficient of x is not 1. So I cannot start solving immediately. I can divide through by 3. I can divide left and right by 3. Because there is equal to here, I can do that. Come in. Okay. Let me make this one to not have any equal to. So on the surface, I can divide everything by 3, but I can divide only the first 2 by 3, or I can factorize 3 out. I can say 3 into everything, x squared plus 5x over 3 plus 1 over 3, if I like. Okay, let me make this square bracket because I'm going to put another bracket inside. this can become 3 into, now this x in this bracket now, I want to now do completely the square in this bracket. So I have open brackets x plus half of this is 5 over 6. To divide the fraction by 2, divide the numerator by 2 if possible. In this case, can we divide the numerator by 2 without remainder? No. Then multiply the denominator by 2. So 3 times 2 is 6. This is half. Close bracket squared minus 5 over 6 squared plus 1 over 3. There is 3 outside the bracket over 3 into, we have this x plus 5 over 6 squared. Everything here becomes negative. It becomes negative 25 over 36. So let me turn this one to have 36 under also. 36 divided by 3 is 12. Okay. So this and these are equivalent. Equal to 3 into x plus 5 over 6 close bracket squared. We sum this and sum this to get negative 13 over 36, negative 13 over 36. Then I can bring this 3 back, equal to 3 into the bracket, 3 into x plus 5 over 6 squared, negative, this negative, 3 into this 3 cancel 36, I will left 12 in denominator, so 13 over 12. There is no equal to, it's an expression. This one is an equation, number 6, it's an equation. So how do I solve it if it is an equation? It's very similar. Better still, I can divide through by 3. So I say x squared. Okay, let me change it. I want to have fraction. Let me change this one to maybe negative. I'm coming 15 times 3 times 4, 60. Negative. Let me say. Negative 8. No, negative 8. Negative 8. Now. No, I don't want 8. Let me just use 11. Negative 11. So, this is minus 11 over 3. I'm dividing by 3, isn't it? Divided by 3, all true. X plus 5 over 3 equal to 0 over 3, which is still 0. It is still 0. So because it's an equation, it's convenient to divide it by 3. So I can do complete the square now. X minus half of this is 11 over 6. Close bracket squared. Minus, no matter what is inside the bracket, put minus aside. This 11 over 6 squared. Then plus 5 over 3 equal to 0. X minus 11 over 6 squared. This becomes negative 121 over 36 plus, if I should make this 3 to be 36 also, 36 divided by 3 is 12, 12 times 5 is 60. So x minus 11 over 6 squared. Sum these two, numerator I have negative 61 over 36 equal to 0. X minus 11 over 6 squared equal to 61 over 36. Okay, I think I misjudged the space. Sorry, I have to do that those last 2 lines again. I have x minus 11 over 6 squared. Sum that minus 61 over 36. 0. X minus 11.
This is what we do in the masterclass, really. We try as much as possible to ensure that we're able to properly, right, teach learners how they can properly understand, interpret the question as much as possible. We dive deeper than just a past paper to ensure that at the end of the day, they're able to fully understand any question that is being administered to them.
1 over 6 squared equal to 61 over 36. So if I take the square root on both sides, I have x minus 11 over 6 here. I have the square roots of 61 over 36. Don't forget plus or minus. Now, because 36 has a root, I will put the root of 36 as 6. So I should be having root 61 over 6. So, let me divide this here. X becomes, taking this approach becomes plus 11 over 6 plus or minus root 61 over 6. So x is the smaller one, 11 minus root 61 over 6, or we can run 11 plus root 61 over 6. Since they are both over 6, I can combine them together. Now, our next question right now should look at when there is inequality. When there's inequality. Okay, so there is inequality here. So we say stop this. Don't forget that this is negative now. This one is negative. Okay, if we solve anything like this earlier on, I don't think so. Okay, when x square is negative, I can arrange. I'll put x squared first. Negative 3x squared plus 2x plus 9 less than 0. I can factorize 3 out, or negative 3 out. Negative 3 into x squared minus 2x minus 9. No, I'm factorizing 3 out, so this should be negative 2 over 3 and positive 3 divided by 3. Sorry, that's negative also. Negative 3. So negative 3 close brackets less than 0. I can as well divide by this, but let's say I'm not dividing by 8. Okay. Now, I can look at minus 3 into open the square x minus half of 2 over 3. If I can divide the numerator by 2, divide. So this is 1 over 3. Minus 1 over 3 squared minus 1 over 3 squared again outside, then minus 3 less than 0. Now, should I divide it by 3? Yes, I can divide by this negative 3. We have to make this inequality change direction. Now, let me say that I have divided this by 3. Then this inequality will change to the other direction, like this instead. Okay? I divided by negative 3. 0 by negative 3 is still 0. So I don't need this bracket anymore. So now let me write that line. I want to solve one that doesn't have equation. So that means that I can remove this one here now. I've divided it. So I can say at this point, complete the square x minus half of this is 1 over 3 squared minus 1 over 3 squared minus 3 greater than 0. Now, so you can say this is x minus 1 over 3 squared. This is minus 1 over 9 minus 27 over 9 greater than 0. X minus 1 over 3 squared minus sum is of 28 over 9 greater than 0. Now, I can take this one across to the other side, so I have x minus 1 over 3 squared is greater than, taking it across become positive, 28 over 9. So I take the square root of both sides, that means x minus 1 over 3 is greater than plus or minus root 28 over 3, because root 9 is 3. You know this one is 2 root 7. I say 2 root 7 in short form. Okay. So from here, I can take it across x. X is greater than negative and positive 1 over 3 plus or minus. Okay, you know what? I shouldn't do this because if I do this, I'll need to get my point. So from this point, I made a kind of blunder from this point. So let me go back. I made a blunder here. Now, what I should have done instead is to see this as a square, a root of the square. Or what is the form of the square? So I need difference of two squares there. So x minus 1 over 3 squared minus the square root of, okay, let me just write it like that. The square root of 28 over 9 greater than 0, all squared, or this square after the square root. So x minus 1 over 3 squared. Okay, let me write it again. No, let me just write it like this. So I can say this brackets minus root 29 over 3 root 28 over 3, I mean, in a bracket, and then into that first bracket plus, sorry please, my writing 3 plus root 28 over 3, okay, greater than 0. Now I have x minus 1 over 3 minus 28, the square root of it over 3, or let me just join it together this way. So minus is common, minus 1 plus root 28 over 3. Sorry about that. So x minus 1 minus root 28 over 3. Because I'm putting minus outside in brackets, I'll take the sign greater than 0. Now, at this point, we're going to look for critical values. Critical values are, this is similar to writing x minus a into x plus, okay, let's say x plus a and x plus b less than, greater than 0, okay? Greater than 0. Now, greater than 0. The critical values here are negative a and negative b. We are negative a, negative b. Negative a and negative b. These are the roots of each bracket. And in this case, the critical values here, I have 1 plus root 28 over 3, 1 over 3, and 1 minus root 28 over 3. So now, let's look at the nature of this curve. Originally, this curve Okay, from these points, I can say that x squared, when I look at this point here, hold on please. So from this point, x squared is positive. X squared is positive, right? I can say that the graph looks like a curve. At this point, x squared is negative. Look like a curve. Okay? Our original equation is this, so I could use this one. So it is looking like a curve. So I'm going to use that original equation. So therefore, x squared is negative. So look like a curve. Let's say this is a curve. And then I want to draw my x-axis. If this is my x-axis coming like this. These are the two critical values. This A and minus B. So these are the two critical values, minus A and minus B. Two critical values. So from this, we are looking for where the equation is less than 0. It's from this value here. So negative infinity, from this value here to positive infinity. Based on this, I can say that x is less than negative a and x is greater than negative b. See, these values here, x values here are greater than negative b. This one here, x values are less than negative a, given that negative a is smaller than negative b. On that note, you can apply that to this one that is kind of complex in that is having solve form roots. As I said, that based on these critical values, which one is smaller? This is smaller. So I can say that x is less than the smaller one. Because we're looking for where the graph is less than 0. Less than 0 is below. Less than 0 is below. These are the value regions less than 0. So from here below, not this is above 0. So on that note, so that case we can write x pregnant. Which one is smaller? This one, because the leading one is negative here. 1 minus root 28 over 3. And then an x is greater than the bigger one. 1 plus root 28 over 3. Now, exercise. Pause the video and solve these questions. Okay, so now that I've solved this question, we cannot continue to the other part of the video. Discriminants of a quadratic equation. Now, in a quadratic equation, if you have something like ax squared plus bx plus c equal to 0, and then we solve, and then we get x equal to the quadratic formula minus b plus or minus square root of b squared minus 4ac all over 2a. Now, what's going to determine the turning point is this bracket. Let me not say turning point. This is called the discriminant. Now, b squared minus 4ac is called the discriminant of the equation. So let us see one or two examples. So let's solve this one. Find the discriminant in the following equation. So in this case, the discriminant is b squared b squared minus 4ac is equal to b is minus 3, so minus 3 squared minus 4 into a, minus 10 minus 3 squared minus 4 into a is 1. 1 into c is 5. This gives me 9 minus 20. This is negative 11. Let me change this one. Let me change this one to maybe so in this case b squared minus 4ac, b is 13, so I'll say 13 squared minus 4 into a is 3. I think I've changed it. I was thinking that it may not. Let me go back. I was thinking that I won't get something. I make it 2. Minus m. Then 4ac. 4 into a is 3. C is negative 6. So I'm going to get 4 here. Minus times minus is positive. This gives us 24 times 3 is 72. This is 76. And then the next one, b squared minus 4ac gives us.
This is what we do in the masterclass, really. We try as much as possible to ensure that we're able to properly, right, teach learners how they can properly understand, interpret the question as much as possible. We dive deeper than just a past paper to ensure that at the end of the day, they're able to fully understand any question that is being administered to them.
20 squared minus 4 times 25 times 4. So that is equal to 400 negative, okay, 400, and this is 0. Now, looking at these examples, let's compare the discriminants. For the first one, okay, now let me go back to the discriminants. Okay, let me just do this. Now, in this discriminants, since discriminant is 0 here, is negative here, that means that no real roots. No real roots. Since discriminant is positive, here, two real distinct roots. And in this case, this one equal roots. So ABC. In case of A, ABC is my x-axis and my y-axis and my x-axis. B, it is my y-axis, x-axis. C, y-axis, x-axis. Now, when there are no real roots, the curve will look like this. Just come like this, it will touch the x-axis and then go back. See that no real roots. In the case of this one, B, this B part, the curve will actually cut the x-axis at 2 points. So those are the 2 solutions of the equation at 2 different points. If it is equal to 0, in this case, the curve will touch the x-axis at 1 point and go back. This is one solution. 1 root. This is 1 root. These are 2 roots. Okay, in this case, 2 roots. Okay, in this case, no root. Okay, b squared minus 4ac is negative, less than 0. this case, b squared minus 4ac is positive, greater than 0. This case, one root or same root, let me call it same root. Same root. So same root b squared minus 4ac is equal to 0. Okay? Now, let's go on to the other parts of this equation. Solving simultaneous equation, one linear, one quadratic. How to solve this? This one is even simple because y is subject in the two equations. This is equation 1, equation 2. Y is subject. Just equate the two of them. Equates equation 1 and equation 2. Therefore, we have x squared minus 3x minus 1 is equal to 2x minus 7. Since this is y, and y are the same, right? So take everything on the right to the left to the left. X squared minus 3x, these 2x come here, become negative. Then minus 1, minus 7 comes here, becomes positive, equal to 0. So x squared minus 5x, sorry, I've solved that later already before writing it, plus 7. Minus 5 plus what? 6 equal to 0. So two numbers that can multiply and get 6 by add up and get minus 5 plus 3. Minus 2 minus 3. X squared minus 2x. Now, okay, I know that minus 2x minus 3x plus 6 equal to 0, but I can use another method for this. I know that the numbers are minus 2 minus 3. X that minus 2, x minus 3 equal to 0. So x minus 2 is 0, or x minus 3 is 0, x equal to 2, or x equal to 3. That's the solution. Next question. Show that there are no real roots for this. First of all, combine them. Substitute for y. When I see y, put this. So y is this. So say x squared minus 2x minus 1. Since y is subject to both of the equations, we equate y equal to x minus 5. So x squared minus 2x, bring this across, negative x. The minus 1, bring 5 across, positive 5, equal to 0. You have x squared minus 3x plus 4 equal to 0. So I have minus, okay, minus, okay, let me see. Okay, minus 4, minus 5, minus 7, minus 2. Okay. This one I have to, I don't think I can factorize this. I can do completely the square here. X negative. Half of this is 3 over 2 all squared minus 3 over 2 plus all squared, and that squared also plus 4 is 0. X minus 3 over 2 squared. This is negative 9 over 4 plus 16 over 4 is 0. X minus 3 over 2 squared plus 7 over 4 is 0. So in this case, I will see that x minus 3 over 2 is equal to, okay, negative 7 over 4, which will be, I didn't say this question properly. So I can use minus 10 and plus 2. So 5x squared minus 10x. Okay, I can use minus 10 and plus 2 to get this. So in that case, I can just do this x minus 10 here and plus 2 here. See this 5 with x squared, use it to divide the two of them. Okay? Which one is possible? This one is possible. So x minus 2 into x plus 2 over 5 equal to 0. So x equal to 2 or x equal to negative 2 over 5. Solution. So now, on that note, you have your exercise. Let me check. Okay, that's it. Your exercise. And that brings us to the end of this exercise. So,
this is what we do in the masterclass, really. We try as much as possible to ensure that we're able to properly, right, teach learners how they can properly understand, interpret the question as much as possible. We dive deeper than just a past paper to ensure that at the end of the day, they're able to fully understand any question that is being administered to them.